Here's a little lecture for lesson 107. It's convergent geometric series. So first we learned about geometric sequences, and then we learned if we put the plus signs in between them and add all the pieces of all the terms of the sequence together, that's called a series. And this is, I think this is in the last video. I showed you one of these or a couple days ago. But so what we like to do sometimes is find out if we had an infinite series, would they add up to a certain number? Or in other words, there's this little formula here that says sometimes if a series is going down, like if it's, like here, let me give an example. If I had something, maybe it went like 16, and then it went 8, and then it went 4, then it went 2, ... If you see something like this, and you think it's geometric because you look at it and you go, well, it's not adding or subtracting. It looks like it's multiplying by a half, right? Taking half of each one, or you can say it's dividing by 2. Something like that, if I put plus signs in between each one of them and add them up, now they'd keep getting smaller, right? Because this would be half of 2 would be 1, and half of 1 would be a half, and half of a half would be a quarter, and you get it, it would get smaller, smaller, it would be having all these little tiny fractions. Well, it turns out that if you had an infinite, if you just expanded this out infinitely, this thing will end up adding up to a certain number. Or it won't exactly add up to a certain number, it will approach a certain number, and that's called a limit. That's one of the things that we study in calculus. But the way you can find out like what number this would add up to, and this only happens when the things are getting smaller, right? Because you can imagine if it was getting multiplied by 2, you know, I could have 6 and 32 and 64. It would just blow up, and it would just go to infinity. Like if I had 100 of these terms and added them all up, well, it just keep getting bigger and bigger. It wouldn't converge on a same number or on a certain number. It's called converging if it actually adds up to a certain number. This one actually will. And there's a formula for that, and it's right here. So remember, this only works if R, remember R is your little multiplier, if R is less than 1, or, well, they like to say this, if the absolute value of R, they like to do this. Or no, if R is in between -1 and positive. Basically, if R is a fraction, you know, it's like less than 1, or it can even be a negative number though, then you can use this formula to see what the thing converges to. Like this thing, I can see what it converges to. I'll do it right. Oh, I'll do it right now. You take the first term, a sub 1. So in this case, it was 16. And then you divide by 1 minus R. So that'd be like 1 minus a half. Well, that'd be 16. 1 minus a half is a half, and if I divide 16 by a half, I actually end up with 32. So it turns out if I added up all these numbers and I kept it going on into infinity, depending on how far I go, I would get ever so close to 32. Just like if you want to read in your book, they got ever so close to 1. Okay, so that's kind of a calculus concept. I don't want to spend too much time talking on it, but we're just going to be answering questions. Does this series converge or diverge? So let's look at some problems. 107, number 6, I already wrote out some of it. So remember, I wrote my formula, and the absolute value of R has to be less than 1, or in other words, these things have to be getting smaller. So let's see what R is. So what's this thing getting multiplied each time? It looks like a third to me. Let's see, is that really true? Does this times a third give this? Yes. Does this? Yes, it's a third. So r is a third. Now, if you didn't know that just by inspecting it, you could take one of these and divide it by the other. Like you can take one term and divide it by the one before it, and you would find r that way. But a lot of times you can just inspect and you can say, okay, it's r. r is 1/3. So if r is 1/3, I can use my formula. So this is actually going to add up to a certain number if I keep going out infinitely far. So a sub 1 is 4. I'm following my formula, and then 1 minus 1/3. Well, what's 1 minus 1/3? 2/3. 4 over 2/3. And then, so that would be the same as 4 over 1 times 3 over 2. I'm getting 6. Let's see if that's right. Yep. Okay, get it? I'm going to do, since I have more time on the video and since I didn't talk about it, I'm going to do I'm just going to do the next problem, the one about the rabbit or the hare. Okay, so he runs 4 miles. So I think I'll go like this. First minute, second minute. I don't know how many they're going to give me. Let's see. He runs 4 miles in the first minute. 2 miles in the next minute. 1 mile in the next minute. How far will the hare travel if he runs forever? So that's like an infinite series right there. So I can imagine, if I want to, I can imagine that this, it looks like it's getting cut in half, doesn't it? This is like a half. And it's a half. And so that would be, right, and then be a fourth. And you can see that the farther out I go, the smaller, they become negligible. You know, they become like adding very tiny amounts. So I find out what r is, and then I get out my formula. My formula was a sub 1, so that's 4, over 1 minus r, but r is a half. So that's the same as 4 over a half. That's going to be 8. So if that hare runs forever, because he keeps going like such a small, you know, half of what he ran the day before, he's only going to get 8 miles. Okay, and that's it.